This presentation is part of a lecture series on the C++ programming language by Michael Adams at the University of Victoria in Victoria, Canada. And for those of you who might be interested, a copy of the slides for this lecture series can be downloaded from the website whose URL is given at the bottom of this slide. So having looked at operators and expressions, now we're going to move on to looking at control flow constructs, such as constructs for selection and looping. The first control flow construct we're going to look at is the if statement, and the if statement allows conditional execution of code. The syntax of the if statement is as shown here. We have if followed by, in parentheses, a Boolean expression, in other words, an expression that evaluates to true or false. And if this expression is true, statement 1 will be executed. Otherwise, statement 2 will be executed, in other words, the statement in the else clause. Now the else clause is optional, so it can be omitted, in which case you have a syntax which looks something like what's shown here. And also, if you string together ifs and elses, you can construct a multi-way if. So for example, in this case, if expression 1 is true, statement 1 will be executed. If expression 2 is true, then statement 2 will be executed, and so on. And then if none of the if conditions are true, then statement n will be executed. Strictly speaking, an if statement can only have a single statement appearing in the body of the if or the body of the else. Often, however, we want to have multiple statements, and this is not a problem. What we can do if we have multiple statements, like what we have here, so for example, in this if statement, if this expression is true, then we want to execute multiple statements. And if the way we handle multiple statements is we take all of these statements here and we group them between a pair of brace brackets. So we have an opening brace bracket here, we have all of our statements, and then a closing brace bracket here. And the brace brackets essentially group all these statements together so that they're logically treated as one statement inside the body of the if. And we can do a similar thing with the else clause as well if we have multiple statements that we want to execute. I would strongly recommend that you always include the brace brackets even when it's not necessary. In other words, even when the body of the if or the else only have a single statement. Because this prevents a certain type of bug, which is a bug which arises when the first version of your code only has a single expression inside the if or the else clause. At some later point, you decide to add a second statement, but you forget to put the brace brackets in, and then your code will probably end up not doing what you expect. And it may actually compile and not do what you expect. So this, by always including the brace brackets, you can avoid this type of problem. On this slide, we have a few examples of if statements. In the first example, we have an integer variable x, and we want to figure out whether x is even or odd, and then print a message corresponding to whether x is even or x is odd. So the condition that we're testing here is checking to see if x is even. So we take x, we take the remainder after dividing it by 2 and check if the remainder is 0. In other words, if it divides evenly. If it does, x is even, and we print the message x is even. Otherwise, we print x is odd. In the next case here, this is an example of an if statement without an else clause. So we just test for this condition, basically testing again to see whether x is even. If it's even, we just print x is divisible by 2. And the last example here is an example showing sort of a multi-way if, where we're testing several different conditions. So if x is greater than 0, we print this message here, which says x is positive. Otherwise, we go on and check, is x less than 0? If it is, we print x is negative. And then otherwise, if neither of those conditions is true, we print x is 0, because this is the only case that remains. The next control flow construct we're going to look at is the switch statement. And the switch statement allows conditional execution of code based on the value of an integer expression. So the syntax of the switch statement is as shown here. So we have switch followed by, in parentheses, some integer expression. And the way that this works is this expression is evaluated, it produces some integer result. And if this integer result equals this constant integer expression here, the code will jump to this and start executing the statement right after this case clause here, so we'll start executing here. If this expression is equal to this constant expression here, the code will jump down to right after this case statement and start executing statements here, and so on. So it's basically evaluating this expression and then either jumping here if the expression is equal to this constant expression, or it will jump here, or it will jump here, or if it doesn't match any of these values, it jumps to the default clause and starts executing statements here. These expressions that are denoted const expr1, const expr2, and so on are constant integer expressions. In other words, they're expressions that can be evaluated at compile time. So you can't have variables, for example, in any of these expressions. And once the code jumps to one of these cases and starts executing, the execution continues until a break statement is hit. On this slide, we have an example of using the switch statement. And in this example, we have an integer variable x. And what we want to do is, based on the value of x, we want to print one of three messages. Either we want to print x is 0 or 1, or x is 2, or x is not 0, 1, or 2. And the way we're going to achieve this is with a switch statement. So we switch on the value of x, and the switch statement is like a fancy multi-way goto statement. So in the case that x matches this value here, the value 0, we'll jump down to the first statement after this case 0 clause here and start executing code from here. In the case x is equal to 1, we'll jump down to this case clause here and start executing code from the next statement after it. In the case x is equal to 2, we jump down to here and start executing code here. In the case that x is none of these values, we'll jump down to this default clause and start executing code from here. And in each case, we will keep executing code until a break statement is hit. And this is important to understand. For example, notice that after this case clause, we don't have a break statement here, which means that once we jump, if x is 0 and we jump to this case 0 clause and start executing, we'll fall through into the next case because there's no break statement to stop us. And we'll execute this line and then stop when we hit the break statement, and it will kick us out of the switch statement altogether at that point. The next control flow construct we're going to look at is the while statement. And the while statement is an example of a looping construct. The syntax of the while statement is what's shown here. We have while followed by an expression in parentheses, and this expression is an expression that evaluates the true or false. It's a Boolean expression. And as long as this expression is true, this statement will be executed repeatedly. And just like in the case of the if statement, the body of a while statement can only have a single statement. So this can only be one statement. If you want to have multiple statements inside the body of the while loop, then what you need to do is group them together with brace brackets. So you put an opening brace bracket, then all the statements that you want to be in the body of the while statement, and then a closing brace bracket here. So these brace brackets effectively group all these statements together so that logically they're treated as a single statement. And as in the case of the if statement, it's advisable always to use the brace brackets even when they're not needed, just to avoid certain classes of bugs. On this slide, we have two examples of using a while statement. In the first example, what we're trying to achieve is to print out hello 10 times. So we create an integer variable n, we initialize it to 10, and then we're going to loop as long as n is greater than 0. So the first time through the loop, n is equal to 10, so it's certainly greater than 0. So we print this message, and then we decrement. This is a decrement operation. We decrement, in other words, subtract 1 from the value of n, so that then n will be 9. Then we go back up to the top of the loop. Is n greater than 0? Yes, it's 9. So then we go through the loop again. We print hello, and then we decrement n, so n goes down to 8. And we keep repeating, and eventually n will be equal to 0, in which case this condition will no longer be true, and then we will jump out of the while loop, and the while loop will end. In the second example here, we're looping while true. So this is a literal Boolean value true, which is basically always true. So this condition will always be true, so we'll keep looping forever, and we'll keep printing hello. So this will never terminate, it will just print hello forever. Another control flow construct in the language is the for statement. And the for statement is an example of a looping construct. Arguably, it's one of the most common looping constructs used in the language. And it has the syntax shown here on the slide. So we have for followed by some stuff in parentheses followed by some other stuff. So what happens with this for loop here, if you look at these lines below here, when this for statement is hit, first we execute statement 1. Then we take this Boolean expression and evaluate it to see whether it's true or false. If it's false, the for loop terminates and it's done. If this expression is true, however, then statement 3 is executed. Then after statement 3 is executed, statement 2 is executed, And then we go back to effectively what's the top of the loop, and we test this condition again. If it's true, we continue on, execute statement 3, and then execute statement 2, and then we test the expression again. So we keep looping until this expression becomes false. And just like with most other constructs that we've talked about so far, control flow constructs, if we have multiple statements that we want to put inside the body of one of these constructs, like if we want to put several statements in the body of a for loop, we have to enclose them in brace brackets, which effectively groups multiple statements and logically treats them as a single statement. And maybe the last thing that I'll comment on in the slide is that in this statement, the one that executes one time before the main iteration of the for loop begins, you can actually declare new variables here. And if you declare new variables here, they only exist for the duration of this for loop. In other words, their lifetime or scope is only the duration of the for loop. After the for loop terminates, any variables that were declared here or defined here are reached the end of their lifetime and go out of scope. In case it may be helpful for you to better understand the for statement, it's worthwhile to point out that you can always express a for statement in terms of a while statement. And in particular, if we have a for statement which looks something like this, we can always rewrite it equivalently in terms of a while loop in this way. In other words, the for loop, we first execute this statement, statement 1. Then we keep looping as long as this expression is true. So we keep looping while this expression is true. And what happens inside the body of the loop is we first execute statement 3, the thing inside the body. And then just before we start the next iteration of the loop, we execute statement 2, which is this statement here. So this might help you to better understand the for statement by showing how you can express it in terms of a while loop. On this slide, we have a few examples of using a for statement. In the first example, we're just trying to print the integers from 0 to 9 inclusive. So to begin, we're going to define a new variable I, an int variable I, and initialize it to 0. We're going to keep looping as long as I is less than 10, and at the bottom of each iteration of the loop, we're going to increment I, in other words, add 1 to I. And each time through the loop, we're going to print the value of I followed by a new line character. So this is going to loop for I going from 0 up to 9. Then the next example in the middle here, this is another example of using a for statement. The only purpose of this example is to illustrate how you accommodate multiple statements in the body of the for loop. So in this case, you can see we have multiple statements in the body of the for loop. So because the for statement itself, strictly speaking, can only have a single statement in the body of the for loop, what we do is we take all of these multiple statements here, we group them with a pair of brace brackets. So we have opening brace bracket here, and the corresponding closing brace bracket here, and all of these statements in between are grouped together into logically one statement, which executes in the body of the for loop. And lastly, this last example on the slide is to illustrate the scope of any variables that are created in the initial statement for the for loop, the very first statement that we have here. And in this case, you can see we're actually defining a new variable I. So the scope of this variable, or lifetime of this variable I, is only the body of this loop, like while this loop is running. So in other words, I only exists from the time that we first are about to start the loop to the time that the loop ends. So if we try to use the value of I here, this will generate a compile time error because I no longer exists once this loop terminates. In C++, there's another entirely different syntax for the for statement, which is referred to as a range-based for statement. And this is a variant of the for statement which is used for iterating over elements in a range. So the best way to illustrate this is by way of an example. So suppose that we have an array of ints. Basically, we have an array of 4 integers, 1, 2, 3, 4, and we want to loop over each of the elements in this array and multiply them by a factor of 3. We can use a range-based for statement, like what's shown here, in order to achieve this. So basically what happens is we're going to loop for each element in this array. The thing that comes after the colon is some kind of container or array, something that holds a bunch of elements. And we're going to loop over each of the elements in this container. In this case, it's an array with 4 elements. And each time through the loop, this variable here, the thing to the left of the colon, is going to take on the value of one of the values that are stored in this container, this array or some other type. So the first time through the loop, x is going to be a reference to, well, x is a reference to an integer, so it refers to some integer. The first time through the loop, x will refer to the first entry in the array. The second time through the loop, x will refer to the second element, and then the third time through the third element, and the fourth time through the fourth element. So each time through, x is going to refer to successive elements in the array called array. And each time through the loop, what we're going to do is we're going to take the value of x, and x is referring to one of the elements in the array, either 1, 2, 3, or 4, and we're going to multiply it by 3, its value by 3. So the first time through the loop, x is going to be referring to this value here, and we're going to multiply this value here by 3, so the value 1 will be replaced by 1 times 3, which is 3. The second time through the loop, this variable x will be referring to this entry in the array. So when we multiply this entry in the array by 3, this value 2 will be replaced by 2 times 3, which is 6, and so on. So this is what we call a range-based. The next control flow construct to be introduced is the do statement. And the do statement is another example of a looping construct, and it has the syntax that's shown here on the slide. And basically what the do statement does, we have a single statement in the body of the do loop. And essentially what happens is the do loop will first of all execute this statement, then it will test this Boolean expression that appears in parentheses here. In other words, it's an expression that evaluates to true or false. And if this expression is false, then the do statement is done. If the expression is true, then the whole process repeats. We execute this statement again, and then we evaluate this expression again, and so on. As is the case with the other looping constructs we've discussed so far, you can only have a single statement in the body of a do loop. So if you want to have multiple statements, then you have to group these statements together by enclosing them in a pair of brace brackets. So we have an opening brace bracket here, then we have several statements, and then we have a closing brace bracket here. And these brace brackets serve to group all of these statements here together so that they're logically treated as a single statement. And again, I would recommend that you always use brace brackets even in the case where there's only a single statement in the body of the do loop, simply because this can help to avoid certain types of bugs. On this slide, we have a couple of examples of using do statements. In the first example here, we have a do statement that has a single statement in the loop body. And essentially what we're doing, we're initializing an integer variable n to 0 before the loop. Then each time through the loop, we're incrementing this variable n, and we're looping until n is greater or equal to 10,000. So this is basically just a delay loop. The second example that we have here is an example where the body of the do loop contains multiple statements. We have a statement that's doing some output, basically printing some stuff to standard output, and then incrementing the value of n. And because of this, we need to enclose these two statements in brace brackets. So we have an opening brace bracket here and a closing brace bracket here. Earlier we talked about the switch statement, and in that context we saw that a break statement provides a way to terminate a switch statement. As it turns out, a break statement can also be used in the context of looping constructs, and in particular it can be used to terminate loops early. On the bottom of this slide we have an example illustrating the use of a break statement, and in this particular example we use a break statement in order to terminate a while loop early. So if we look at this code example in more detail, we have an int variable x, and then we have a while loop. And in the expression for the while loop, as a side effect of evaluating this expression, an integer will be read from the standard input stream into the variable x. And this expression will evaluate to true if the input operation was successful, and will evaluate to false otherwise. So we'll keep looping as long as we successfully read an integer value into the variable x. Then inside the loop, we're checking to see if x is negative. And for some reason, if x is negative, we want to terminate the loop early by executing a break statement. If the if condition's not true, then we'll continue on and print out the value of x to the standard output stream. If this break statement is taken, in other words, if this if condition is true and then we go inside the if and execute this break statement, the effect of executing this break statement is the control will be passed to just past the end of the while loop. In other words, the while loop will be terminated and we'll start executing the next statement after the while loop. In the context of looping constructs, another very useful statement is the continue statement. And what the continue statement does is it causes the next iteration of the enclosing loop, in other words, the loop that encloses the continue statement, to be started immediately. And I have an example to help illustrate the use of the continue statement. So if we look at this code example here, the key thing to note is we have a for loop and we have a continue statement that appears somewhere in the body of the for loop. And with the for loop, if you recall, the first thing that happens is we execute this statement here, which is going to define a new integer variable I and initialize it to 0. Then it tests this condition, and if this condition here is true, if I is less than 10, then it will execute an iteration of the loop. And at the very bottom of the loop, it will increment I just before it starts the next iteration and retest this condition I less than 10. And inside the body of the loop, we have an if statement, and then inside the if statement, we have a continue statement. So if this continue statement is hit, what happens is that the flow of the program will automatically jump from the continue statement down to just before this brace bracket. In other words, it skips over everything else in the body of the for loop and proceeds on to the next iteration. So this is what's achieved by the continue statement. And the continue statement can be used with other looping constructs as well, not just the for loop. It works with other looping constructs as well. Another control flow construct in the language is the goto statement. And what the goto statement does is it transfers control from one statement to another statement that's specified by a label. Now, before I go into any examples illustrating the goto statement, I just want to point out that you should avoid the use of the goto statement unless you absolutely need it. And there's very few legitimate uses for the goto statement, simply because the other control flow constructs in the language usually allow you to do most of the sorts of things that you want to do in a much cleaner way than the goto statement. That said, I'll give an example. This example is not meant to be a particularly good use of the goto statement, but just to illustrate exactly what it does. So in this particular code here, the important thing to note is that we have a goto statement here, and we're telling it to go to a particular place which is specified by a label, this label loop. And then up above, you'll notice that there's a label, basically the label followed by a colon. So this is labeling a certain point in the code as loop. And when we say go to loop, if this statement is executed, what will happen is the code will jump from this place here where the goto statement is up until the statement where this label appears. So it will basically start executing this do statement again. Again, only use the goto statement if it's absolutely necessary. And maybe one other thing to point out about the goto statement, you're only allowed to use it in certain ways. For example, this code here would generate a compile time error because in this case we're trying to skip over the creation of a variable. We have this variable I here, this integer variable I being created on this line of code, and we have this goto statement which is trying to go to the line that's labeled as skip, which is this line down below here. And then after this point, we're trying to increment I. But if we actually execute this goto statement, it actually jumps over the line of code that creates I. So it would be complete nonsense to try to increment I here because I never even got created because we've skipped over its creation. So for example, one restriction on the use of the goto statement is you can't jump over the initialization or creation of variables in the same block as the goto statement.